Hello students, in this session we will discuss about stacks. A stack is a data structure. A stack is a data structure where insertions and deletions are done from one end only, right? So example of a stack in our daily life can be a stack of plates. That is, the plates when they are arranged one on the other, it is an example of a stack. Or books which are set in a rack, not like one above the other. So that is an example of a stack. Or you may be having stack of chairs where the chairs will be arranged one above the other just to keep it aside. Even that is also an example of a stack in our daily life. If you see there, so take the example of a chairs, the stack of chairs there. If you wanted to remove, you will not remove it from the bottom, but you will remove the topmost one. You will remove the topmost one. If you wanted to put something, put either chair on it, you will put it on the top only, but you will not put it at the bottom or somewhere else. So the same concept stands here also, right? So stack is a data structure where insertions and deletions are done from one end only. That end is called as a top. Then it follows a mechanism like first in, last out, or last in, first out. First in, last out, or last in, first out. Right? Now, coming to a diagrammatic representation, suppose this is the stack. Suppose this is a stack. Suppose, let us take that I have a stack which is holding some integer elements. Let the stack size be 5. Right? That is how I use to represent stack using array. Right? So 0, 1, 2, 3, 4. Right? So I have this much of stack. Now, as of now, when the stack is empty, when it is just created, the top will be at -1. The top will be at -1 because I'm talking about a stack using an array. Initially the first element of the stack will be at 0th position, then 1, 2, 3, 4 as we have seen in arrays, right? Now, if I did not insert any element into it, then obviously where will be top, because top is the position from where insertions or deletions have to be done, right? But as you see here, there is nothing inside the stack still. So the position of the top will be at -1 position. So as of now, the empty stack's top will be at -1. Suppose I inserted a new element into it. I inserted one element into it. Suppose I inserted 23. Okay. So where is top now? Top is at 0th position. So the top will be here. Right. So that is about how an empty stack will be represented and where will be the top when a newly created stack is there. Right. Now, suppose I have something like this. Top is here only. My top is here only. Right. That is, as of now, there is nothing in it. Now, I wanted to insert an element into it. That is, I wanted to add an element into it. Right. So how do I add? Or I wanted to delete an element from it. How can I do that? These are the different operations we can perform on a stack. The different operations I can perform on a stack are, I can push an element into it. Push means to perform addition, or to insert is nothing but to push. I can pop an element from the stack, nothing but I can delete an element from the stack. Next, I can find out whether the stack is empty. I can find out whether the stack is full, or I can even get the topmost element of the stack. Right? So apart from this, you can create a stack. Of course, that is a common one. Right? Now, coming to the very first one, push. We'll discuss about this now. Push. What do you mean by push? To add an element. Right? To add an element. As of now, it is empty. I wanted to add a new element into the stack. Suppose let it be some 25. I wanted to add 25. So obviously, where does it go? It will go and settle in the first position, that is at the 0th position. But if you can see, top is at -1. So what should I do? I have to make the top to move front, move up, move one step forward. Then I have to save it here. So what should I do first? First of all, I need to make top plus plus. I need to make top plus plus. Then what happens? Top comes here. Top comes here. That means top plus plus -1 plus 1. 0. So 0th position, top is at 0th position, then only I can insert this 25. Right? Now, if I wanted to insert one more element, suppose I need to insert 18 again, that means I wanted to push 18 again. So if I wanted to do that, again what should I do? I have to increment the top position by 1, then only I can insert the element. That means I should make top plus plus. Okay, then what should I do? I have to put the element in that particular location, right? So top plus plus, then I can do stack of top is equal to what? 18, as we have discussed. Then I can put 18 and my top is here. In that way, insertions are done. So whenever insertions are done, I need to increment the top position by 1, then only I can insert a element into it. Right? Now, I wanted to pop an element from it. That means I wanted to delete an element. When I am deleting, first of all, I need to decrement the top position. That is, I need to decrement the top position by 1. Then what happens automatically? Top comes to the next line. So automatically top is not there. So this will be my top. And before that, whatever is there is simply ignored. Right? So in that way, we will pop an element. Simply decrement the top by 1. Decrement the top by 1. And that is how element will be deleted automatically. Okay? Right. Now coming to is empty. When do I say the stack is empty? See, whatever we are doing with connection to top only. Isn't it? So where is top now? Top is at 0. That means I have one element in it. Right? So in that way, when do I say that the stack is empty? When is it empty? When there is nothing in it. When there is nothing in it, then automatically top should be at -1. So if top is equal to -1, then I can say that yes, the stack is empty. And when do I check this one? Before delete operation, that is before performing a pop operation, I need to check whether there is something in the stack so that I can remove. So for that case, I need to check whether it is empty. If it is not empty, then only I can perform the pop operation. Otherwise, I cannot perform. Coming to is full is nothing but when the stack's capacity is full. When you can't insert any more elements into it, then I say that the stack is full. That means the maximum capacity is reached. For example, in this case, we have taken the size as 5. Okay, so suppose that yes, we have put all the elements here, and now the top is here. The top is here. Where is it? At 4. If you check, its capacity is 5. So when the top is at maximum capacity -1, maximum capacity is 5. Now what I'm saying, top is at maximum capacity -1. Now I can say that yes, the stack is full. That means it is in a overflow condition where you can't insert any more elements into it. Okay, that is about is full. So when do you say that the stack is full? When the max capacity, or when the top is at max capacity -1. In that case, we say that the stack is full. Here in this case, we cannot do any further insertions, right? Then comes while you are inserting an element, before you insert, you need to check whether the stack is full. If it is not full, then only you can insert, otherwise you can't. Coming to the next one is get top. This operation will give you the topmost element of the stack. Means, for example, the top is here. I say the top is here. Now, I wanted to know what is the element at the top. How do I find out? How do I get that? I simply give cout stack of top. That's it. I simply give it like this. So what happens? Stack of top. Stack is nothing but the name of this block, right? And top. What is the position of top? 3. So stack of 3 is nothing but 11. In that way, I can get the topmost element of the stack, right? So these are the operations we perform on the stack. In the next session, we'll see how to implement these operations using a C++ program. Hope you understood the concept of stack. Thank you.